So as we have generated the zonal statistics of a dam of Amochu watershed or river basin, so we have to calculate the or generate the hypsometric curve in Excel. So first of all, so here you can see zero value, so you have to remove this one in order not to have the errors in the calculation. And then we don't require this count, delete this one. And then also we don't require this standard deviation sum and etc. So in order to calculate the or generate the hypsometric curve, we have to have the minimum minus mean, that is maximum and minimum data of the particular DM. Then we have to calculate the hypsometric integral. So this hypsometric integral is the ratio of volume of landmass or area below a given contour line to the total volume if the landscape were a flat surface at the highest elevation. Or in simple word, it helps us see how eroded or youthful a landscape is, that is represented by HI. Then we have to calculate the area accumulation represented by small letter A, and then we should have calculate area, small area divided by the total area for the relative area. And then to calculate relative height, we have to calculate small h, and then small h divided by capital H is relative height. So here is the formula to calculate the hypsometric integral, that is hi equals to E minus E minimum divided by E max minus E mini, min. So E with the slash overhead represents mean elevation, then E mean is minimum elevation, and then E max is maximum elevation. So if the hi, that is hypsometric integral, is above 0.6, then it is in useful state. If it is in between 0.35 to 0.6, then it is in mature state. And then if it is less than 0.35, then it is in old stage. So here I will demonstrate how to do all these things out here. Just have a look and then enjoy the tutorial. So since the area is in meter square, meter, I have to convert it into square kilometer. The formula is equals to the area in meter divided by 1 million. So this average will let us know in which stage the erosion cycle is in or the river is in. So out here you can see it is 0.48, which is in between 0.35 and then in 0.6. So it represents it is in maybe meter stage. So to keep the value static, you have to press Fn F4. Then you have to calculate small h. Then you have to calculate the relative height. So capital H is the total of small h. From here we can create the hypsometric curve. To do so, relative height, and then you'll use relative area. So you have to filter this one, relative area from lowest to smallest to largest, and then the relative height from largest to smallest. Then you can go to insert and select scatter plot, right click and then select data. So to edit series will be the relative area okay. Okay, so it appears like this. Then click here, format series, go here, solid line, and smooth the line. Marker, no marker. Then you can add the what you call axis title. So out here it will be relative height, and then here it will be relative area, and then rest of the thing you can edit. And then if you want to, so next if you want to calculate the percentage of hypsometric curve, then it is quite easy. Just do this, equals to relative divided by, no, divided times 100 equals to relative height times 100. Select all. So out here, right click, select data, select edit, then from here select this one, relative height percentage. Then out here you will select relative area, and out here you will select this one. Okay, okay, and click OK. So here you have the relative percentage, height in percent and then area in percent. So you can have two vertical chart for hypsometric curve.